is on. Yes, I know. Thank you for the notification. Right. Yeah, so today, thank you for coming. Again, we'll be talking about the software defined data center with Proxmox. My name is Achmad Mardiansyah, and I'm from GLC Networks Indonesia. So agenda, we will be talking this topic this evening, introduction, about the review, prerequisite knowledge, about Proxmox virtualization, and then of course the software defined data center with Proxmox. Okay, introduction. We are GLC, Garda Lintas Cakrawala. We are based in Bandung, Indonesia. Our areas are training and IT consulting. We do MikroTik, Ubiquiti, Linux. Yeah, anything related to those things. Yeah, networking, system administration, and then we also do programming. We develop our own product for GLC Radius. We do regular events like what we are doing today for the webinar. My name is Achmad Mardiansyah. I'm based in Bandung. Linux user, MikroTik user, Ubiquiti user, Cisco user, whatever user, Proxmox user, of course, yeah. Python user, PHP user, what else? MySQL user, PostgreSQL users, MikroTik scripting user. I'm trainer, I'm teaching for living. Also do consulting, like doing projects. Also write some articles in some websites. Also, I have LinkedIn account. So guys, if you don't mind, we can connect there on LinkedIn. Past project, we do MikroTik, mostly related to ISP, but not always. So yeah, in several countries. So today, yeah, one of the experience from my past projects. Also, I put some of them in our webinar tonight. So about the webinar itself, we started from January 1st, and then we mostly talk about those topics: networking, system administrations, and then programmings. If you want to be a presenters, thank you. I got one presenters. So guys, if you want to share something, please let me know, okay? And then we put the schedule for you guys, okay? And then for you, introducing yourself, I can see some of you already did that. Thank you very much. Yeah, mostly are Indonesians. If you haven't mentioned something here, please say something in the group chat, okay? Especially your experience, so at least I know your background. Yeah, prerequisites. So this presentation has, okay, I need to update the slides here. The presentation, assume you already have prerequisite knowledge. So we just discuss them in the short period, okay, just brief. Yeah, at least we assume you already know data center, software defined, everything, and then of course the Proxmox. Okay, let's get started. So what is data center? Data center is a building, okay? So the data center is the building that that is used to host components for computer or telecommunications, okay? So this is how the data center looks like. Okay, let me change the color. Okay, so we have a computer racks here, and then yeah, another racks, lots of racks. So the purpose for the data center room is to host the servers, and then they put the servers in the rack. Okay, and then most likely the computer that you put there is on a rack mounted foam. Okay, so it's not like a desktop that you put on your desk. So it's a different foam. Okay, some data center is quite fancy like this. Okay, so we have one in Indonesia. So instead of using original color of the racks, so the provider paint them. Okay, so we have a Four Seasons in Jakarta like this. So actually all of them are racks here. Okay, it's a computer racks. Okay, but they painted the racks to something else. So if you go there for the first time, you will be amazed. So it's a Four Seasons. This is I think this is summer, and this is fall, winter, and then this is spring. Right. Okay. So that was the data center. Let's move on about the data center. So here is the data center components. So the main component, the data center is used to host a computer system, of course, yeah. So of course, this is the main component, right? So that's the reason why we developed the data center. We built the data center. Okay, so of course the component that you will put there is the server and rack. Okay, so just like this. Okay, you put the computers here, here, here. Okay, and then these are the racks. Of course, in order to make the one computer and then the other computer connects, you need a networking device. Okay, so like a router, switch, firewall. Okay, so perhaps one of them is firewall, for example. And of course, there will be a cabling. Yeah, otherwise, how can you connect? Most likely, people are just use fiber optic cables. Okay. But many are still using the traditional one that is based on copper, like Cat5, Cat6, Cat7. Of course, all of them need power supply. Okay, so this is one of them. This all the batteries for inverters. Okay, so in case there is, of course, they have a backup power like generators. So, so if one generator down, or if a main supply of the electricity down, then there will be a backup. Next is cooling. Okay, so this is, for example, cooling. Okay, so the cool air coming from the bottoms and then will be sucked by the servers. So front of the server is like this. Okay, that's the front. Okay, so usually the arrangement of the racks is front to front or back to back. Okay, so if you open the tile here, so if you open, then it will be like this. So the cold air is coming from the bottom here. Of course, there will be a fire suppression system like this. So if there is a fire, in case there is a fire, and then the inside here, actually the inside is a gas, okay, to suppress the oxygen. So fire, if you see fire, fire can exist if they have three components, right? They have materials, they have oxygen, they have what else? They have heat. Okay, so materials and then oxygen. So the purpose of fire suppression is to eliminate the oxygen. Okay, make sure oxygen is not there, so we can suppress the fire. Okay, so that's very cool feature. Etc. Etc. Okay, but the main important components are these, right? So a computer system, networking device. Okay, so that's the main component of your data center. If you have a very good power supply, good cooling, good fire suppression, but no computers, and then for what? Why do you need to build a data center, right? So this is just example of data center cooling. Okay, So as you can see here, we have, this is the racks. Okay, so this is the front. So this is front. Okay, and this is back. Okay, so the water, the cold air is coming from the bottom, sucked by the, it's yeah, absorbed by the front panel. Okay, both panel. Okay, and then there will be a server here. Okay, the server generates heat. The heat goes to the back side of the racks, and then it will be absorbed by the panel on top, and then uh, will be forwarded to other cooling, and then the circle goes on and on. So this is how it looks like. Okay, so so at the bottom, so usually they have a rise floor where the air condition pump the cold air over here, and then the cold air will be coming out from the bottom. Okay, so we have a cold aisle and then hot aisle. So this is how the typical data center cooling. Okay, so it's back to back. So, but we are not talking about, we are not talking much about the data center. It's a dedicated topic, how to develop a very good data center. Okay. So let's talk about the SDE or SDX, software defined everything. So SDX, so because currently we are moving toward to the software. Okay, so started from SDN. Okay, so previously when we talk about networking, we talk about hardware. Okay, either it's router, either it's switch, either it's firewall. Okay, you name it. Okay. Switch, router, okay, firewall. So most of them are just we call it what it's just is hardware. Okay, so you have to buy a hardware, and then that becomes the software, the networking. Okay, so with the SDN, okay, we try to virtualize this one. So we emphasize on this software. So inside the router, actually, there is a processing, right? So packets come and then will be processed by the kernel of the router operating system, and then will be forwarded to a specific destination. Okay. So SDE is defined as a physical or functional can be performed with the software. Okay, so the emphasis here is the software. So the software that can do anything that was previously done by physical items. Okay, so previously we have a hardware networking. Now we do a software-defined networking. So the function for networking, like routing or switching, or checking the packet inspection for a firewall, is done by software, not only the hardware. Okay, so next also we have software infrastructure, software defined radios, the storage, data center, WAN, LAN, etc., etc. So the main emphasis for SDE is the software. Okay. So what about the components? So because we emphasize on software, okay, the software component here. So mostly as the X products, usually they must have an abstraction. Mostly they have a virtual system on that, and then they allow machine-to-machine communication here. So of course they will provide API. Okay, the API that is used to program the components. Okay, so that's the SDE. Okay, next is about the Proxmox. Okay, so Proxmox is an open source server management platform for enterprise. Okay, yeah. So Proxmox is open source, and oh, wait a minute. Yeah, so it's open source for virtualization. Okay. It integrates the hypervisor, aka hypervisor. So the one that is doing the virtualization is called hypervisor, and then the hypervisor here can be based on KVM or containers. Okay, they don't provide Docker here. So yeah, if we're talking about the virtualizations, we have two options. Either you want to virtualize full, or you want to virtualize some of them. Okay, so full virtualization is called VM. Okay, or if you want to start virtualize from the operating system to the top, so you're focusing on applications, you call it container. And on Linux, you have option for container. You can use LXC, you can use Docker. Okay. Yeah. Yeah. So Proxmox is alternative for VMware. So previously, VMware is focusing on VM, virtual machine. So it's simulate from the hardware. Okay. So if you install operating on top, the operating system think that, oh, okay, I'm installing here on the hardware. So the operating system here. So we have a hardware, okay, and then you put KVM. So you are emulating hardware. So you have a virtual hardware here, virtual hardware, and then on top of that you put your OS. So if you use VM, the benefit is you can use any OS. So you can use Windows, you can use FreeBSD. Okay, you can use Linux, of course, etc., etc. So that's the definition. That's the main difference between virtualization with the VM versus container. So with the container, so you install here is the hypervisor. This is hypervisor. So if the hypervisor is Linux, okay, like Proxmox here. So the LXC that you install here must be Linux as well. You cannot install LXC, Linux LXC on the Windows kernel. You cannot. Or Linux kernel, and then on top you have a container of Windows. No, you cannot do that. If you want to install Windows, and then you have to use the VM. Or maybe in the future, Microsoft decides that their product is based on a Linux kernel, but that's another story. Okay. Oh, I have a question here. Is it ideal for enterprise? Yes, 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 yes. It's used for enterprise. About support, yes, they provide support. Of course, you have to pay for them. If you compare virtualization, yes, as I said, this is a alternative for VMware. So VMware mostly is used for VM, okay? But Proxmox can do VM and container. Okay, so two different things. Okay, so VM and container. So Proxmox can do both of them, but VMware mostly they are focusing on the VM. Okay, Oracle VM. Oracle VM is based on the Linux kernel, so they are using a KVM as well. Okay, so hopefully that answered the question. So how the Proxmox looks like? Well, Proxmox looks like this. So this is a Proxmox interface. And then you will see this is the nodes. Okay. Yeah, the newer VMware supports container, but I'm not sure what kind of container it supports. Is it Linux container? So because I never use VMware Tanzu, yeah, I'm not really have a deep idea about the container from the VMware. So the very good things about the container is very lightweight. Okay, I have two. Most of the so previously I used KVM. But now most of my virtual machines on my our development machines are based on container here. Okay, right. So this is container. We have they have a storage, they have a networking, they support VLAN, etc. and etc. Okay, so let's move on. So let's talk about the software defined data center, SDDC. Okay. So SDDC actually is just a marketing term. Okay. So there's nothing technical here. So the technical actually is the software defined storage, software defined networks. Those are more technical. But SDDC is just a marketing term. So saying that because we are able to do SDN, because this is what happened, right? You have racks, okay? You have racks, and then you have router here, okay? You have a server here, okay? You have switch here, okay? And then so on and so forth, okay? And then you connect to the internet here, okay? And so on and so forth. So that router, that switch can be put, can be used. We can create, because currently most of the server are in a virtualization form, right? So why don't we just use the server, 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 server? We can consolidate them. We can group them into one big group. And then on top of that, so we have a server, 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 server. I mean the server hardware here, okay. And then we installed a hypervisor. So Proxmox is a hypervisor, like a VMware. So, and then we can combine them, okay. So hypervisor, okay. So we just combine this server. So as here is the server, I mean server hardware. Okay, so on top of that, you can use a VM and then VM and then VM. Okay, VM. Okay. What about the networking? So we can set up another networking. So on top of hypervisor. So let's say we have we can also setting this VMware this VM as a router. Yeah. So we have a virtual router. Okay, and then from this virtual router connect to the switch 1, switch 2, switch 3, okay, and so on and so forth. Okay, and then from switch 1 connect to server 1, server 2. I mean not server 1. Yeah. So in order to avoid confusion with the physical server, so I will say this VM1, VM2, okay, VM3, VM4, okay, so VM2 and 3 connect to this, yeah. So everything that we are able to do at the physical, this is physical data center. Okay, and then here's also physical data center. So that means we don't have to install the physical router. Why? Because we can set up the virtual router as well. What about the firewall? We can install the virtual firewall as well, like FortiGate. FortiGate has their own virtualization version, okay, of FortiGate. If you use Sophos has their virtualization version so that you can install it on VM. So we don't have to buy their hardware. It's cheaper. Okay, we don't have to buy hardware. We just use our VM, install the Sophos firewall. We can use a MikroTik as a virtual router. We can use Viata. We can use pfSense for firewall and so on and so forth. So the idea for software-defined data center, we are virtualizing the component that we discussed before here. Okay. So with the advancements of virtualization software, with the advancement for hypervisor, okay, so we can generate this thing on hypervisor, right? Okay, so that's the purpose for the software-defined data center. So we want to virtualize all of them. Yes, because some people still confuse. How can we virtualize the power supply, cooling, fire suppression? No, no, that's not part of the data center. SDDC, yeah, software-defined data center. So the SDDC focusing on these things. All right. Okay. So let's. Oops. Yeah. Okay. So. Okay. So software-defined data center with Proxmox. Well, this is how, for example, the implementations on Proxmox. Okay, so for example, we can set up so this is the hardware. Okay, hardware, 3 servers. Okay, and then we can set up like a virtualization here. Okay, or KVM or LXC. You can also do a migrations over there. Okay, and also for the storage, Proxmox support network-based storage. So, for example, this hard disk belongs to this server. This hard disk belongs to this server. This server. Okay, so for example, how can you develop a drive that has, for example, 500 terabyte capacity drive? Okay, how can you develop a drive that has 500 terabytes capacity? How can you do that? Yeah, with the storage management, because if you just rely on one single hard disk, the biggest capacity for a hard disk now, single hard disk, is only, I think the biggest hard disk capacity, single capacity of hard disk is only 20 terabytes, correct? Right? You can search in the Amazon or in Tokopedia on any marketplace. So far, the biggest capacity of single hard disk capacity, biggest single hard disk capacity that I found from the marketplace is just 20 terabytes. Okay. So how can you develop a drive? You have a data for example, 100 terabyte data. So how can you build them? Okay, so one of them is using Chef. So how can you do that? So for example, this is a hard disk. Okay, hard disk 1 hard disk 2, hard disk 3, hard disk 4, hard disk 5, hard disk 6. Okay, so each of them is 20 terabyte, for example. Okay, so let me explain how Chef works. Okay, so each hard disk here is attached on physical server. Okay, okay, so each hard disk is attached on physical server. So we install Chef on each Chef on each server here, and then we combine them with Chef like a controller node, so that we can combine all of them, so that we can combine a Chef disk, okay, with the capacity 6 times 20 terabytes. Okay, so equals to 120 terabytes. Yeah, that's how you achieve that capacity. So from the VM point of view, so we for example, we have VM here. So when we install VM, the CPU, the RAM, okay, is from here, but the data is from here. Okay, so this is how it configures. Okay, so we have dedicated server, as I said, dedicated server for storage. Yeah, so if somebody says is SDS software defined storage, yes. So it has a capability of combining those hard disks. So in open source we have many options. One of them is Chef. Others is like DRDB or other technologies like another big data like Sparks or what is it? I forgot the Hadoop. Yeah, Apache Hadoop. Sorry, Hadoop. Yeah, yeah. Hadoop was part of Apache project. Sorry, Apache Foundation. Sorry. So there is a foundation called Apache. Okay, and then that foundation has many projects, including HTTPD, which is the Apache web server, the very famous web server up to now. And then one of their projects that they manage is Hadoop, MapReduce, Sparks, and Tomcat. Many projects. Okay. Yeah. So is it like vSAN? Yes. For VMware, it's called vSAN. So they combine the hard disk from different servers combined into one big group. So that's the function of Chef. Chef is open source. vSAN is not. Okay. Have I ever used the Chef? Yes. But you need to know that because vSAN is Chef is requires between heavily on communication between nodes, because hard disk hard disk between the server here are communicating to each other. So if there is a change, and then there is a replication. If in the case of failure, for example, this one down, and then the data still be able to alive, right? So that requires a high-speed data network. Okay, so yeah, so that's why for Chef, so it is recommended to have a very high speed storage network, which is different compared to the other networks. So I really recommend, if you are installing Proxmox, you are using a multiple interface, probably 10 gig. So for example, this server has two network interface. So one interface goes to goes to safe network that is used for for storage. Okay, and then so this is switch 1, this is switch 2, and then there are different networks, different network ID. Okay, so so the application request coming from here, but the data are installed on here. Data. So yeah, there will be a no bottleneck if there is a request coming from outside. Okay. Right. So Chef combine all this from different physical server to one pool. Yes, correct. So the VM, I just see one data store. Yes, correct. So this is one example of data center with Proxmox. Okay. So perhaps we can do checking. Perhaps I can share our server here, just a development server. So in our development server, we don't, yes, we use Proxmox, and then we develop cluster among them. Oops, looks like it's very slow, the connectivity here. Oops. Oh, connection timeout. What's happening? Oh, it's very slow here. Okay, let me open another server. Yeah, the connection is very slow here. I don't know why. 192. Okay, maybe I check others. Okay, here it is. Okay, so perhaps I can display here an example of our test server here. So it's installed on Proxmox as well. So as you can see, we have several VM here, for example, GLC, and then so they are based on the, what is it, LXC. Okay, so container, and then for example, these are the, yeah, so here it is. we have nodes. We have 4 nodes, 4 physical nodes. Well, actually, they are virtual. Okay. Yeah, so we can do, for example, if node 253 here is down, and then we can move them. So for example, I'll do, I say migration to, let's say 252, for example. Okay, so we expect that this one will move to this. Okay. So this is how it looks like, because we don't use here centralized storage. So yeah, for migrations, it's a little bit slow here compared to if you have centralized storage, because you have if you do migration without centralized storage, and then yeah, you have to copy the whole amount of hard disk into the next to the target server. Okay, in this case from 253 to 252. Okay, is it finished? Yeah, okay, so as you can see, the task here is okay, it's done. Okay, I should see something on 252. Okay, so it's already changed here. Okay, let me close. So now it's on 252. So previously it was 253, right? Okay, so now it's on 252. About the storage, here you can use, there are many storage that you can use. You can add LVM, for example, NFS. Usually for VMware, they use for centralized data storage. People use NFS, but here you have many options. Okay, yeah, you can use NFS, you can use CIFS. Okay, yeah, this is for like a Samba, yeah, SMB. You can use, if you use a cluster FS, the cluster file system from Red Hat, that's cluster FS, or you can use iSCSI, Chef, RDB, okay, ZFS, or this one is not for or operational storage. This is just for backup. Okay, what about fault tolerance? What kind of fault tolerance? So if one down, we can set up a like a high availability here. Also, we can do we can set up a replications here. Okay, or ZFS replication. This is how you set up Chef. Okay, for example, we don't do Chef here because we are running out of hard disk. Yeah, so sorry, we don't do Chef here because currently we are lack of resources. So perhaps in the future there will be a webinar that will be discussing the Chef. All right. Regarding the for example, as I said, okay, so we install a MikroTik here, for example. This is for our test server. Yeah, so as you can see, I can log in and then I can do, oh, what's the password? Oh yeah, oh, no password. Yes, so /IP address print. Okay, so that's the, yeah, that's the IP address. Okay, let's ping from here. Okay, this is the shell. I can ping 10.40.7.47. Yes, yeah, still. So that 47 is this one. So we can do migrate, for example. You want to migrate from 252 to let's say 253. We do migrate, and then you can see during the transfer, as you can see, the server is still accessible. We can still reply the ping. Okay, so it's done. Already moved to 253. Okay, here. Okay, this one here, but we are still able to ping the uh, the routers. Okay, let me put back the router here. For example, we use this for testing the PoE. We put back to 252, for example. Okay, doing migration. Okay, and then during the migration, we do ping the routers. Here, as you can see, yeah, it says almost no downtime. Okay, as you can see, still be able to ping the what is it? The routers. Okay. Also, there is a feature for firewall, for example. Okay, I put here firewalls is yes. Okay, and then I put input policy is drop. Okay, so automatically, if I ping, and then it will reply. It should reply not available. Okay, so yeah, so firewall here is yes, and then from here is also yes. Input policy is drop. Output policy, let's say drop. Okay, should be okay then. And then when you ping, oh, maybe because they are in the one network. Yeah, I need to do, I need to update the configuration later. Okay, guys, anything else? Yeah, so hopefully, so that was the example of how Proxmox looks like. Okay, right. So that was our Proxmox server for testing. Okay. In the future, I think better if perhaps we will schedule the chef. So because that one is kind of cool. Okay. Yeah, same thing. You can aggregate the hard disk into one big chunk of a storage. Okay, so it's end of slides. I think it's time to end the webinar. Thank you very much for coming. So please submit your feedback here. And if you want to know the further events in the future, just go visit our website. We have Facebook. We also put some notifications there. Slides will be available on Slideshare. We also put the slides on our website as well. So just check our website. Recording will be available on YouTube. Just visit our channel. Yeah, that's all. Any questions so far? If not, then I think it's time to photo session. Okay, guys, please open your cameras. So we're going to take some pictures here. Okay, stop share. And let's see the participants. Right, guys. Okay, I will count 1, 2, 3. Yes, 1, 2, and 3. Thumbs up, thumbs up. 1, 2, and 3. Yes. Okay, second page. Oh, we have lots of people here. 1, 2, and 3. Yeah, off you go. Guys, thank you very much for coming. Okay. Hopefully you enjoyed the webinar. Yeah, next time, yeah, we'll discuss another topics. If you have suggestion, and then yeah, just let me know. Okay, any topics that will be discussed in the future. So today, I think we conclude. This is how the software-defined data center looks like. At least you know we have an idea that instead of you build a physical router, physical firewall, physical switch and everything for your data center, why don't you just put everything into one roof? You put everything with Proxmox. You develop networks, you develop firewalls based on the Proxmox, okay? So that could be your idea. Is it enterprise level? Yes, yes, we use in production, but I will not show you the production because it's private. Right, anything else? No? Okay, thank you very much for coming. Yeah, you are welcome. Yeah. What a pity you don't have camera. Again, I will put the feedback link here. Okay, please submit, and then you can write them there. We always read your feedback to make our webinar better. Anything else? Okay, if no, then I will stop the recording, and then I will see you in the next webinar next week. Thank you and have a nice day and keep safe, everyone. Goodbye.